Now we'll see some more concepts on vectors. Along with that, we'll recall whatever you have studied in the theory concepts. Some formulas are there, no? We'll recall those. Okay. See this one. First, zero vector. Zero vector is nothing but a vector which is having a magnitude 0 is called the zero vector and represented by zero vector. Unit vector means it has a magnitude 1. It is represented by n cap. Right? Equal vectors means which has the same direction and the magnitude will be same, then it is called the equal vector. Negative vector is nothing but the magnitude will be same but the direction is opposite. Co-initial vector is nothing but which is having the same initial point is called the co-initial vectors. Collinear vectors, two or more vectors said to be collinear if they are parallel each other. Now here see this one, like vectors and unlike vectors. Like vectors is nothing but two or more vectors which are parallel and having the same direction. That is called the like vectors. Is it clear? Those are collinear only. They are parallel to each other, having the same direction. Then it is called the like vectors. If it is in the opposite direction, two or more vectors are parallel to each other, but they are in opposite direction. Then it is called the unlike vectors. Okay. Collinear is nothing but parallel. Like is nothing but it is having the same direction, parallel as well as having the same direction. Unlike is nothing but parallel and having a opposite direction. Next, coplanar vectors. To say two or more vectors are coplanar, they lies on a same plane or they will be parallel to the same plane. Then it is called the coplanar vectors. These are the different types. See here, we have studied this section formula. If it is a P is a point which divides the vectors which divides the point AB in the ratio M is to N. Then OP vector is a position vector from O to P. OE vector is a position vector that is represented as A vector. OB vector is represented by B vector. Then OP vector, position vector is given by MB vector plus NA vector divided by M plus A. If it is P is the midpoint, then A vector plus B vector divided by 2. If it is A vector, the scalar product of this A vector dot B vector will be equal to A1 B1 plus A2 B2 plus A3 B3. If it is A vector dot B vector is equal to 0, that is nothing but either A vector should be equal to 0 or B vector should be equal to 0 or A vector is perpendicular to B vector. Now A vector dot B vector is equal to magnitude of A vector, magnitude of B vector. If it is angle theta is equal to 0, then it is called the like vectors, right? If it is like this, same, then it is called the like vectors. Then A vector dot B vector will be equal to magnitude of A vector into magnitude of B vector. A vector dot B vector is equal to minus magnitude of A vector, magnitude of B vector. Then the vectors will be like this. This is one, this is another one. So angle between them will be 180 degree. Those are unlike vectors, right? Then A vector dot B vector will be equal to minus magnitude of A vector, magnitude of B vector. And what is the value of cos theta? Cos theta is equal to A vector dot B vector divided by magnitude of A vector into magnitude of B vector. Now, if it is any two vectors are orthogonal, orthogonal is nothing but they are perpendicular, then A vector dot B vector will be equal to 0. We have studied I dot I, J dot J, K dot K will be equal to 1. If it is Ij or Jk or Ki, it will be equal to 0. And commutative law holds under the scalar product. A dot B will be equal to B dot A. Okay. Next, projection of a vector. Projection of A vector along B vector is given by 1 by magnitude of B vector. A vector dot B vector, this is equal to, see here, B vector divided by magnitude of B vector will be equal to B cap, it is unit vector dot product with A vector. If you want to find projection of B vector along A vector, then it will be equal to B vector dot with the A cap. Okay. See this is important. Projection of A vector along B vector will be this one. If I want to find B vector along A vector, this will be equal to now B cap dot, B vector dot A cap. Okay. See this vector cross product is defined as A vector or cross product. A vector cross B vector, magnitude of A vector, magnitude of B vector, sin theta n cap. Here theta is the angle between A vector and B vector. N cap is a unit vector perpendicular to both A vector and B vector. Right? The vector product of A vector and B vector, cross product of A vector and B vector is a vector which is perpendicular to both A vector and B vector. Remember the cross product, A vector cross B vector. Here you will get one vector, right? After the cross product of this you will get one vector. That vector is perpendicular to both A vector and B vector. Okay. See this A vector cross B vector is not equal to B vector cross A vector. It is not commutative. So A vector cross B vector will be equal to negative of B vector cross A vector. We have studied this one in the theory. I cross J will be K. J cross K is I. K cross I will be J. If I want to find J cross I will be minus K. K cross J will be minus I. I cross K will be minus J. Right? This is like this. So this is I. J, K. If it is the direction is opposite, then it will be a negative one. See, A vector cross B vector plus C vector. That is, this is with distributive law. A vector cross B vector plus A vector cross C vector. But associative law does not hold. A vector cross B vector cross C vector is not equal to A vector cross B vector cross C vector. To find this, you know this I, J, K and components A1, A2, A3. Then B1, B2, B3. So vector cross product will give you another vector. Now here sin theta is magnitude of A vector cross B vector divided by magnitude of A vector into magnitude of B vector. Then the unit vector, see this is the important one, the unit vector perpendicular to A vector and B vector. If you want to find the vector perpendicular to A vector and B vector, what you have to find? A vector cross B vector. Is it clear? If you want to find the vector perpendicular to both A vector and B vector, you need to find cross product of this. See here? Here you can see this A vector cross product of this will give you a vector perpendicular to both A vector and B vector. If you want to find the unit vector, then what is the unit vector? If you want to find the unit vector of this, A cap is equal to A vector divided by magnitude of A vector. Right? So this is a formula to find the unit vector. So if you want to find a unit vector perpendicular to both A vector and B vector, then you have to find C n cap is equal to A vector cross B vector, same it is, divided by magnitude of A vector cross B vector. So here n cap is equal to A vector cross B vector divided by magnitude of A vector cross B vector. Now next, area of a parallelogram with the adjacent side is given, then magnitude of A vector cross B vector. If it is diagonals are given, then it will be half into magnitude of A vector cross B vector. Remember this. If it is the adjacent sides are given, then magnitude of A vector cross B vector. If it is the diagonals are given, then half into magnitude of A vector cross B vector. Then triangle half magnitude of A vector cross B vector. Then A vector and B vector are the adjacent sides of a triangle. Then see, this is the important one. The relation between A vector cross B vector cross product and the dot product is given by A vector cross B vector whole square is equal to magnitude of A vector square dot magnitude of B vector square minus A vector dot B vector whole square. So this is the important result. If you want to find the relation between vectors and the vector product and dot product, this is the relation. Okay. Scalar triple product or box product, you have studied. A vector dot B vector cross C vector is nothing but you have to find the determinant of all the components A1, A2, A3, B1, B2, B3, C1, C2, C3. Here A vector is equal to A1 I cap plus A2 J cap plus A3 K cap. Similarly B vector and C vector. Okay. And if it is A vector, B vector, C vector are coplanar, if and only if scalar dot product should be equal to 0. And I will not repeat the properties of this scalar dot product, scalar triple product. Okay, you go through it once, it is important. Okay, properties. Now this is the important one. See, vector triple product, that is represented by A vector cross B vector cross C vector. Another one is A vector cross B vector cross product with the C vector. Here this is nothing but B vector and C vector lies in a plane which is perpendicular to the A vector. Okay, B vector, remember B vector and C vector lies in a plane perpendicular to A vector. Clear? B vector cross C vector lies in a plane. These two are perpendicular to A vector. Here this is nothing but A vector cross B vector cross C vector is nothing but A vector and B vector lies in a plane. These two are perpendicular to the C vector. Here these two are perpendicular to A vector and here A vector and B vector are perpendicular to the C vector. Is it clear? Now see, it is defined as, remember this formula, important one, to find the cross product. A vector cross B vector cross C vector is equal to A vector dot C vector into B vector minus A vector dot B vector into C vector. If it is, this is the condition, A vector cross B vector cross C vector will be equal to A vector dot C vector into B vector minus B vector dot C vector into A vector. Simple. See here, A vector dot C vector into B vector minus A vector dot B vector into C vector. Similarly, you can find this one. Remember, and these two are the important results. See, if G is the centroid of a triangle, G is the, you know about the centroid, right? If it is G is the centroid of a triangle, then remember GA vector plus GB vector plus GC vector is always equal to 0 vector. If it is, this is a triangle A, B, C and G is the centroid, then AB vector plus AG vector plus BG vector plus CG vector is always equal to 0. And another one, if ABC are the vertices of triangle, then AB plus BC plus CA will be equal to 0, right? Obviously. See here, A, B, C, AB, BC and C, A to B, B to C, then C to A. Obviously it will be equal to 0 vector. And if it is, see, AD vector, BE vector and CF vector are the medians of the triangle. AD, BE and CF are the medians, then what we can say, AD vector plus BE vector plus CF vector is also equal to 0. Remember, if it is G is the centroid, then GA plus GB plus GC is equal to 0. Then if you find the medians, then it will be A2 median will be here, something you can consider as D, AD and BE vector plus CF vector is also equal to 0. A vector, B vector are mutually perpendicular. Then magnitude of A vector plus B vector plus C vector whole square is equal to magnitude of A square plus magnitude of B square plus magnitude of C square. Obviously, right? Because you know the formula. What is A plus B plus C whole square? A square plus B square plus C square plus 2AB plus 2BC plus 2A. Here those are perpendicular each other. So dot product of AB will be 0, BC will be 0, CA will be 0, right? By that we will get that. So this is about the vector cross product in linear combination of vectors. Actually this is not important. Just we'll go through it once, okay? Linear independent, there are two types. One is a linear independent, another one is a linear dependent. What is mean by linear independent? See, if it is, there is a system of vectors A1, A2, AN is said to be a linearly independent, linearly independent if there exists a constants M1, M2, M till Mn such that M1 into A1 vector plus M2 into A2 vector till Mn into An vector will be equal to 0. There those constants M1, M2 till Mn should be equal to 0. Then we can say that those are linearly independent. Example is a pair of non-collinear vectors. Remember this, a pair of non-collinear vectors is always linearly independent and non-coplanar vectors is also linearly independent. Non-coplanar vectors is also linearly independent. Linearly dependent means similar to this, there exists a vectors. To say those are linear dependent, there exists a M1, M2 till Mn such that all are not equal to 0. Here in the case of independent all are equal to 0. In the case of dependent M1, M2, Mn all are not equal to 0. Few may be equal to 0 but there some M1, a1 vector plus m2 a vector, this will be equal to 0 vector. Then we can say that those are linearly dependent vectors. Example is collinear vectors and coplanar vectors. Independent is nothing but non-collinear and non-coplanar. Dependent is nothing but collinear and coplanar vectors. This is all about the vector algebra. And one more thing, to say any vector is a free vector if it is the initial point is not specified. If it is the initial point is not specified, then we can say that that vector is a free vector. Okay, remember those things and practice well.